Hello, this is Mrs. Moslake, Geometry, Notes 11.1 and 11.2. Areas of parallelograms, triangles, trapezoids, rhombi, and kites. Do the warm-up, pause the video. When you are done with the warm-up, go ahead and play. Okay, who got 330 meters? Excellent. If you did not, it's really helpful to draw a picture. So draw a picture of a rectangle. It does not have to be drawn to scale. The dimensions are 75 by 90, and they want the approximate length around that rectangular lot. That just means perimeter. So perimeter of a rectangle is just the lengths added together and the widths added together. And so we just have the 75 plus 75 plus the 90 plus the 90. In any order you can add them, and you get the answer of 330 meters. Okay, so perimeter is distance around an object, and it's measured in units. Area is the amount of space inside of an object, and it's measured as square units. So you already should know that area formula for a parallelogram. That includes your parallelogram, rhombus, rectangle, and square. So if you're given any of those four objects, the area formula is just base times height. A triangle is half of that. It's just half of a parallelogram. A trapezoid might be a new formula for you to know. It is just made of two triangles. So if you take a trapezoid and you can split it into two pieces, you have triangle 1 and triangle 2. You're just adding the two triangles. So for instance, if I distribute, I get area equals 1/2 height times base 1 plus 1/2 height times base 2. Height times base 2. So if you want to just kind of see an illustration of this, here's a GeoGebra applet of a trapezoid. And so here we go. You can think about this as two trapezoids, and I am going to make it into one parallelogram. So you can think of this as base 1 plus base 2 times the height, but you have half of that because we only have half of the parallelogram. Or you can think of it the way I explained it in the notes as two triangles added together. And then a kite or a rhombus is 1/2 the product of their diagonals. So here would be one diagonal. Let's call it D1. And then I'll change colors. Let's do red is the other diagonal. So multiply those together. That's a little counterintuitive. So let's again look at a GeoGebra applet to see area of a kite. Here is one made, and so think of this as 4 pieces. Rotate the next pieces together. And so it's really the area of a rectangle, but we're taking half of that rectangle because, again, we're not using both of those sets of pieces. So that's kind of a cool way to think about the one half of the area of the rectangle, and the rectangle is just the diameter 1 times diameter 2. Okay, so hopefully that's helpful for you. So knowing those formulas is a necessary endeavor to be successful in this chapter and the next chapter on surface area and volumes when we're looking at 3-dimensional shapes. So example 1, find the area and perimeter of the parallelogram. Well, let's start with what might be easiest, and that would be, I believe, the perimeter. And perimeter is just distance around. It's your length plus width plus width. And we already know that the length is 48, so another one is 48. And if this side is 36, this side is also 36. So the perimeter is just our 48 plus 48 plus 36 plus 36. Add them all, and we get, 168, and that is feet. Okay, the area is more complicated. We'll write down the formula. So area equals length times width. So or you can think of it as base times height. Base times height. Both formulas are perfectly fine. The base is 48, and we have to figure out what the height is. Now the height is over here, h. So let's use L's here. You could use SOHCAHTOA as well. So here's our 30 degrees, and we have using SOHCAHTOA, we have our reference angle, we have the adjacent side and hypotenuse. So cosine of our angle 30 equals the adjacent side, which is h, because it's a right triangle, h over the hypotenuse, which is 36. Cross multiply, h is 36 times cosine of 30. So that's what we're going to put in here, 36 times cosine of 30. Multiply that out, and it says to the nearest tenth, so we have 48 times 36 times cosine 30, enter, and we get 1,496.49. So we'll say 0.5, and that's square feet. Now, like I said before, you could also use the L's because it is a 30, 60, 90 triangle. Opposite your 30 is L, opposite 60 is L square root of 3, and opposite the 90 is 2L. So we know that 2L is 36, so L is 18. Therefore, the height is 18 square root of 3. So you could have instead here put in 18 square root of 3. Put that in your calculator. 48 times 18 times square root 3, enter, and we get the same amount. So either if you want to use the L's for a special right triangle or SOHCAHTOA, you still get the same final simplified answer. Let's go ahead and try the next problem. So we are reviewing chapter 8 on trigonometry in chapter 11. Example 2, find the area and perimeter of the triangle. Well, the area is much easier in this problem. So area of a triangle is 1/2 base times height. They give you the base, that is 46. So that is your base. And the height is 48. Now, the height does not have to be a part of the triangle. So we have area equals 1/2. The base is 46. The height is 48. So multiply. The base has to be a part of your triangle, but the height does not. It just has to be perpendicular to the base from the vertex opposite to the base. So 1/2, or 0.5 times 46 times 48 is 1,104. And this would be square units. So this is square feet. Now, the perimeter is the more difficult part in this problem. The perimeter is the distance around this object. So we do have this 46 plus 67. I'm going to just label the triangle we want. That is the blue. So we have the 46, the 70, 67, and the unknown. Let's call it C, because that is going to be the hypotenuse of the triangle we're going to be working with over here. So let's go ahead and find C, and we're going to find it by using the Pythagorean theorem. Again, a lot of review of chapter 8 on trigonometry is in this chapter on areas. So we have 14 squared plus 48 squared equals C squared. So 14 squared plus 48 squared is 2,500. Take the square root of both sides. Show that you're taking plus or minus. And our answer is the positive value because it is a length of the side of a triangle. Okay, so we had to do that in order to finish this problem. So the perimeter is 46 plus 67 plus 50. So 50 is the side of C. So 46 plus 67 plus 50, answer is 163. Make sure you put units, and that would be feet. Okay, that was probably one of the harder problems to do, number 1 and 2, and now we just get easy, but these can get quite complicated. So instead of giving you the height, I could give you sides of this right triangle, and you would have to use either SOHCAHTOA or your L's using special right triangles. So area of a trapezoid, remember that is 2 triangles added together, or you can think of this as a base 1 and base 2 added together, and we have 2 of these base times height. So we're going to take half of this height and the sum of the bases. So two ways to think of the trapezoid formula for area. So the height is 15. And one of the bases, it doesn't matter which one is base 1 and which one is base 2. So let's just call this base 1, this base 2. Again, it does not matter which one is base 1 or base 2. So we have 18 plus 40 or 40 plus 18 because we have the commutative property for addition. Does not matter the order that you add. 18 plus 40 is 58. So now just multiply 0.5 or 1/2 times 15 times 58 and we get 435. So area is 435. Use units, so this would be square meters. And last problem is find the area of the kite. Remember, the area of a kite formula is like, for instance, we have these 1, 2, 3, 4 regions. If you double them, then you have a rectangle, and the area of a rectangle is length times width. Your length is the diagonal times the other diagonal. So we just doubled that right here. So 1/2 diagonal 1 times diagonal 2. So one of the diagonals is going to be 16 plus 16. And the other diagonal, we had to figure out. One piece is 35, but I need to find the other unknown. Let's just call it x. Now, if you remember in chapter 6 on quadrilaterals, the diagonals of a kite are perpendicular. Very important concept to either remember, just understand. It does make sense. And so we have this right triangle right here. So we can use the Pythagorean theorem or Pythagorean triples. Let's use the Pythagorean theorem. A squared plus b squared equals c squared. So x squared plus 16 squared equals 20 squared. So we have x squared plus 16 squared is 256 equals 400. Subtract 256 from both sides. So x squared is 144. Take the square root of both sides. Make sure you show your plus or minus. And x is the positive 12. So we have right in here is 12. So we have a equals 1/2 times 16 plus 16. And then times 35 plus 12. So we have area equals 1/2 times 32 times 47. So in our calculator, 1 divided by 2, or 0.5, times 32 times 47. And we have the area is 752, and that is square meters.